Plastic as a building material? No way! This cannot be true. Ethylene tetrafluoroethylene, also known as ETFE, is a plastic derivative that is frequently used as a building material in the form of ETFE membranes. It is originally invented as an insulation material for the astronautics industry. The product is commonly used as roofs, facades, and skylights. Some few examples applied in buildings is the Parkville Green in China, Alliander HQ in Netherlands, and the Alliance Arena in Germany. So, how does it work, you might ask? The production of ETFE involves the transformation of the monomer TFE into the polymer ETFE using polymerization. The material is then extruded into varying thickness in a thermoplastics manufacture machine, which is a water-based procedure, a process which uses minimal energy. It is then packed, distributed, and installed on aluminum frames as desired designs. ETFE is applicable in most climates, rain or shine, in many different countries such as Singapore, Germany, China, and many more. It is also primarily used for buildings which builds over a large span. A good local example is the roof at the Southern Cross Station in Melbourne. ETFE seems to be a fantastic material with lots of advantages. Firstly, ETFE films can be up to 90% transparent. This creates the best conditions for photosynthesis and therefore plant growth. In order to reduce light transmission, ETFE membranes can be printed with highly reflective patterns and colors. ETFE films also have an exceptional resistance, a particularly high elongation at break. It also has a long service life and requires low maintenance as it is extremely weather resistant, self-cleaning, and hardly ages. A great example is the Mangrove Hall at Burgess Zoo, which exists in 1982. ETFE is also flame retardant as it doesn't burn, although it can melt before it self-extinguishes. In addition, from extrusion to assembly, ETFE materials consume significantly less energy than glass or comparable building materials. ETFE films also have a lightweight and a low raw material cost in production. This saves costs for the substructure. Its ability to cover large spans also enables cost savings. When ETFE films are replaced after their long service life, the waste material is fully recyclable and can be upcycled into different ETFE products. Last but not least, ETFE is extremely flexible, which makes any design possible. However, every good thing is always too good to be true. ETFE itself has its own limitations too. ETFE is after all a plastic, a man-made material. ETFE is also meant for large-scale buildings. Therefore, it is too complex for small residential projects. Finally, ETFE transmits more sound compared to other materials, which causes it to be unsuitable for buildings which requires good sound insulation. This assignment is done by Danica Gan, student ID 2190365508. Thank you for watching.